this working? Okay, I think it works. Alright, here are the bunch of questions that I made. I'm just waiting for him. Come into Zoom. Definitely gonna ask these questions. I don't know about. Probably just gonna pick from some random ones here. I don't know how long this is gonna go for. I don't know how to add someone. Like, what if someone just comes in the room? Can I just add them? Hey, what's up, physics guy? Yo, I need you guys to like help me out. Like, if I don't have any more questions, just like come up with some random question. Yeah, let me see what he said. Yo, why is no one joining? Let me see. Did I do something wrong? Like, can no one join for some reason? Um, okay, we can just look over the questions while he's not coming. Okay, so first question is, can you tell us how you got interested in physics? Pretty straightforward, I guess. And then, yeah, so oh, hello. Hello.
Yeah, okay. Can you hear me?
Yeah, can you hear me?
Yeah, everything seems to be fine. I was a little late because I had went biking and then Zoom started installing once I launched it. So sorry about.
Yeah, no problem. Yeah, so it's really nice to meet you uh, for the first time. So, yeah, I have like a
Yeah.
lot of questions, and it'd be really, really cool if you can answer a couple of them.
Okay.
Yeah, so I have some questions, and then I also asked the Discord server, like, hey, do you have any questions for you? And they have like a lot of them, so then, like, I have about
Okay.
like 10 questions, like 10, 15 questions.
Okay. Just a moment. I'll switch on light here.
All right.
Uh, so All right. So I understand you have a lot of questions, right?
Yeah, yeah, yeah.
Okay. Now, asking those questions, maybe it's easier. Okay. You can start from somewhere.
All right.
So,
So I guess the first question is, how do you get interested in physics? Like, what is your background in that?
oh, okay. It was quite a long time back. Uh, um, well, uh, I started at school, which was not very big and very prestigious school. Um, and we did not have almost no physics teacher over there. But I was quite good in math, and so I got into the regional maths Olympiad. And
Mm-hmm.
then there was like it was a part of Tallinn, capital of Estonia, and then regional team to Estonian. Okay, sorry. So what I won for my eighth year. It was eighth year. How middle school, probably the last year of middle school qualifies when we should have had 2 years physics, but actually it was almost non-existent. But we had quite okay math teacher, and so we got into regional team to the Estonian final round of mathematics. But that final round was the team was led by the best school in Tallinn and probably one of the two best schools in Estonia. Teachers from there were supervisors of the team. And
Yeah.
so during that competition, they convinced me that I need to transfer to the other school, to that school where they were from. And so I did that, and then without that, I probably would have stayed where I was. But thanks to those teachers, I transferred school, and then last 3 years of high school I spent there, and we had really good physics teacher. We had both good math teacher and physics teacher, so I was successful in both. And but my homeroom teacher was math teacher, and she tried to convince me a lot for me to continue studying math, but somehow I happened to get into the Soviet physics team. And so this pretty much like I felt that okay, physics is for me more suitable than maths, and so I started studying physics after that. And then yeah,
Yeah.
well, I think I need to stop here. So I can see it's quite random coincidences and things which determined where I went.
Yeah, I see, I see. So you basically just like stumbled upon it because your teacher told you, hey, like this would be a interesting thing that you could do.
Yeah. So well, they just uh, well, um, I mean, after that middle school, end of middle school, yeah, yeah, actually that was a physics teacher who was the leader of the team, and she also like said, no, no, you are stupid if you're still going to stay there. You need to go. And then there was a very good math teacher with whom I had during over summer. We had like short meetings with the math teacher, and so yeah. Well, but then the physics teacher who was with me was 3 years. She was really very good teacher. Actually, she knew actually could solve all these Soviet round physics problems and
Oh,
like actually I don't think any other teacher in Estonia at that time was as good as our teacher was.
oh wow, that's awesome.
Yeah.
Yeah. Uh, yeah. Then I guess similarly, like how I guess let me think. Like I guess how did you get into physics Olympiad preparation? Like what textbooks did you read, and then what would you recommend like people now to read?
Oh. Actually, I am very bad at recommending good books because I myself have read very few books. And so during university course, of course I did read some books, and after that as well. But I usually tend to find books too long to a lot of unnecessary text, and as soon as I can do something myself, I try doing it myself. And then if I cannot do, then I'm starting to looking for it here and there. So as for my preparation during, let us say, high school and university years, well, I don't think these textbooks what we had were good, but there were quite a lot of good physics problem and math problem collections. So I can actually tell more or less how my homeroom teacher in maths and physics, how they taught me, and also how it went in the university. So actually, it was quite similar for both maths and physics, that the teachers gave, we had, apart from me, there are also a few guys who were quite good. And so they gave us books with problems, like a math teacher had some book in Russian with math problems. At that time, I was not that good in maths, but the text in maths are quite simple, and it was still understandable. And then we tried to solve it, and I don't remember how about the math problem solutions. But physics teacher had quite a similar, but she had like glued on cards, like perforated cards, problems from different physics Olympiad rounds, like regional, Estonian, Republican rounds, and also those Soviet physics Olympiads, and so one side had a problem, and I think on reverse, or was it on different cards that I don't really remember actually, was a solution. So while she was dealing with other students, we were just solving those problems and checking by ourselves our solutions on reverse of the card. And so no really textbooks, but if I was unable to solve something or did not understand a solution here or there, then she explained me what the situation was, and so so when you were asking about the textbooks, then actually I must disappoint you. And
Yes.
and university, yeah, of course we did have textbooks in Russian. So there was that. I don't know if you have seen those books, but there was actually, I was during my first year, I was in Tartu University, and then I transferred for second year. I transferred to Moscow Institute of Physics and Technology, and in Tartu, I think we had that easier or simpler or shorter book which was written by a Russian guy, Savelyev, which was like a textbook for technical universities. But it is still up to this day, I consider this quite an okay book, which has no nice figures as modern books, but it was no obvious mistakes and quite well explained. But then in Moscow Institute of Physics and Technology, MIPT, there we had like a more serious book of physics, which was written by Sivukhin, a professor in that university. And that's like a much thicker book, which has usually during university courses, actually not everything is covered. So some chapters are there in small letters, like not obligatory, not mandatory chapters. And that was like served as a basis, but then again, actually, I think what mostly promoted understanding of physics were those home assignments, or not actually, these were not home assignments, but a collection of problems which every student had to solve by the end of the semester. Something like 15 to 30 problems, quite not too easy problems. Um, so. So yeah.
Yeah, I see. So basically, you learn the most by like solving problems, I guess.
Exactly. And of course, there were also reference books, but I was attending also lectures, and so because of attending lectures, I really did not need to open much books, but only opened those problem collections and solved them.
Yeah, I can see that like in your study guides, like you have like little theory, but then like a lot of problems for people to
Yeah,
solve.
yeah, yeah,
Yeah.
yeah, yeah, yeah.
Um.
So, and I still consider actually now I when I'm comparing how in this or that university students are studying, tend to think that in quite many and quite good universities they have still too much of theory studies and instead they could focus more on problems. Like I think. It is still quite okay in Oxford and Cambridge, but some other European universities just students need to study some formulas and then answer during oral examination, and I don't think that is very helpful in.
Yeah,
But
I see.
well, so yep.
Okay. Here's another question. Let me see. Um. Oh yeah. So, how is the Olympiad scenery like in the 1980s? Like when you competed, like compared to now? Like what is it? Was the experience like any different?
In Olympiad, you ask.
Yeah, yeah. Like we're going to the International Physics Olympiad, like meeting people there. Do you find that experience like different when you were there compared to like now?
Well, definitely. I was when I was there. There were only 17 countries, so
Oh
it was
wow.
much smaller. Problems, if we speak about International Physics Olympiad, problems were also much shorter, and well, it's gradually became longer and longer and longer, and yeah, well, which mm, I don't think is a good thing, but that's another story. So that was the main difference was it was shorter and program shorter and smaller number of countries participating. Other than that, the format is still the same.
Yeah.
Yeah.
So wait, what? So why do you like dislike the longer problems compared to the shorter ones?
I believe that why I don't like longer problems, they take off creativity from the students. Basically you build up a problem so that it is the solution of the problem's author, which the students need to get, not their own solution, because they are guided through it. So
Yeah.
you take off freedom to devise their own way from the students, which is not how physics research works. So in physics research, everyone needs to figure out by themselves without no one guiding.
Yeah, I agree. Like I like the UFO problems like compared to the
Mm,
IFO. Yeah.
yeah.
Um. Let me see. Um. Oh yeah. So like you've written like a lot of like physics problems. So, like how do you write good problems? Like where do you get your inspiration from and like stuff like that?
Well, different problems come in a different way. So uh, sometimes those are actually the best problems. I believe when you notice something. And then in nature or in your surrounding, I think, that seems interesting. Then what is the physical reason? And you figure it out. then okay, but this can be made into problem, and then you make it. So just if you keep your eyes open, and from time to time you'll manage to notice things which can be made into problems. That's one thing. But the other thing is that once you have already seen many problems, and so you know many tricks how they are solved, then you can actually make a problem around an idea. Okay, this is a problem idea which is supposed to be used, and then let us make a problem around it, and try to make as natural as possible configuration of it, not very artificial setup, and yeah, problems built around the ideas of how to solve. And I think this is because it is quite difficult to get problems just by noticing something. And then majority of the problem, I guess, are built around an idea of how to solve it.
I see. I see.
But when you make a problem, how do you know the solution is correct? I mean, when you make the
when I build a problem around ideas, and because first was a solution and the problem came later, then of course the solution is correct, unless I make a wrong problem. But then if it is the other way around, if you have problem first, well, you have the feeling that okay, this must be correct. There is no because everything fits. So basically, you need to be convinced in your solution. Of course, sometimes you don't notice something, and sometimes you still make mistake. But actually, the main thing is that you need to feel that it is correct.
So then, like, say, like your physical problems, like how long do you take to write those? Like, how long does it take?
How long does it take to make problem?
Yeah.
It can be different. It can be different. Some problems are like you work quite a long time on it, but the others come quite much faster. So, for instance, that you remember maybe that crystal ball problem from European Physics Olympiad.
Yeah.
Yeah. So I worked quite a long time, and also I involved a friend of mine to make photos needed for that. So it started with a cylindrical configuration, the same phenomenon of refraction, but on a cylinder. And then we did not find quite a good polished cylinder, so we needed to have quite a good quality photo. At first, the cylinder seems like, if you look at it, it seems nice, but because refraction kind of magnifies very strongly inhomogeneities on the surface. So the quality ended up not very satisfactory. And then I think that friend of mine said, okay, but I don't have cylinder, but I have a ball. And then I found, okay, ball might work even better. And then we went into with the ball. But actually, we worked quite really quite a long time, and then the EUF academic committee members also helped to improve over there and check and yeah. But in other cases, if it's easier or simpler or more straightforward, it can just be something like maybe 15 minutes or so, just to write down things.
Yeah, I see.
And yeah, now recently saw some simpler problems which go to Estonian regional rounds and final rounds. These also, I'm teaching in university now thermodynamics and electrodynamics. So some problems which I go to give to students over there also can be double used for Olympiad problems. So
yeah, I see. Okay, and then what do you say your favorite problem is that you ever wrote?
My favorite problem on physics.
Yeah, that you wrote. Or I guess like
that I
also
wrote
your
myself. Okay. I think I have. I like that problem from the problems from UFO. I think my favorite probably what was that water stream of water from a hose.
oh
Uh,
yeah, and
yeah,
then like the graph.
yeah. And then I like also the cat eye problem. When you need, you remember that
Yeah, yeah.
the problem is cat eye. But I think some physical problems also. That crystal ball problem, I think it's also quite okay problem. And so you for 2012 problems with the cylindrical building and when you need to throw on top of it.
Oh yeah.
And then probably also the magnetic straw problems from the same 2012 IP show. And yes, then probably also some physical problems, but I think it's already quite enough, isn't it?
I mean, yeah, those are all great problems. Yeah. Let me think.
And I had a question that tips on arranging Olympiads when resources are low in places like Bangladesh. Like from your experience, is there any tip that you could recommend for arranging Olympiads and stuff
So
where it's
exactly
not that popular?
what kind of resources? So you have access to internet and you can download programs from there, and then I think that's what you should do. So
Exactly.
yeah, the main problem might be that your if your environment is not very encouraging, like you have a lot of load from high school, which is you don't think it is important. You can always try to optimize a little, solve a little, get a little lower grade here or there, and make instead use the time for solving physics problem.
Yes, got it. But in the sense of organizing an Olympiad, like we have regional Olympiad, national Olympiad, so we kind of don't have all those resources like arranging like uh places to take exams on and stuff. But my question is exactly is in a logistical way, I mean, what's the best way to arrange an Olympiad in your experience?
How to logistically arrange it?
Yeah, yeah, your tips from your experience.
Okay. Uh, well, uh, I'm not quite sure if I understand your question correctly. So basically, the situation in Estonia and in Bangladesh are quite different. Bangladesh is
Yeah.
quite big, Estonia is small. So in Estonia, you usually don't have any logistic problem at all. You just need to have a room and everything. Everyone can come in within a couple of hours from their home by buses. And but in Bangladesh, it's probably much more difficult, larger distances and maybe you can
Yeah.
elaborate what kind of problems you issue and what kinds of problems you have encountered and then maybe.
Usually the problems include we don't have venues, we don't have enough budgets, and we also sometimes we don't have enough people, and it's not quite popular. Olympiads are not popular, and so we don't really get to have like talented people. They are not aware of Olympiads. It's a multidimensional problem. So, uh, yeah.
But in that case, you can try doing it online if students have access to internet.
Yeah, that's a solution. But when we are like doing like, I mean, you have been like arranging Olympiads for like a lot of time. So do you have any advice regarding that? That would be great.
No, okay. Mhm. Uh, well, In our case, like those Estonian final round and so-called open physics Olympiads, each of them of those has their own format, which is a little different and which might or might not be helpful for you. So I can describe how they are organized, and I think they usually, in general, work quite well. So probably what is most relevant for you might be how we organize so-called Estonian Open Olympiad, which is Olympiad where everyone can participate, don't need to have gone through preliminary rounds. That's why it's called Open Olympiad, and open competition, not Olympiad, open Olympiad, but open physics competition, and it has regional headquarters, so to say. Like we have in 5 different places in Estonia, we have a room where there is a supervisor and a room where students can solve and where the problems are printed and distributed to the students. The solves are in 5 hours, and then sets are collected and sent to the academic committee of the Olympiad. So that's something which might help organizing it in those cases when you have low budget and no money for travel and things like that. So it's kind of a compromise between online and real life. So you have students meet in real life somewhere, but only those who live nearby. And then it's more controlled environment as well, because sometimes students might think that okay, this and that are cheating if this goes completely online, but in that case it's still controlled. There is supervisor in each of the rooms where students solve.
Yeah, got that. Thank you.
Yeah.
Okay. Yeah, awesome. Let me think. So, I guess a lot of people from the Discord, so a lot of them are trying to get into like physics in college. So, like, do you have any advice, like, what, any advice on like what they should do, like what they should expect?
So advice of now, what kind of advice? So like how to prepare, or where to which courses to select or aim for, or like can you be more specific with the advice?
Yeah, let me look. I guess how do they like get into research, and then like what should they expect, like compared to like Olympiads?
Okay, yeah. Now, well, to begin with, of course, going for physics undergraduate is a correct choice. That's for sure. So, because with physics education, you don't need to stay in physics if you eventually don't like it that much, but you have good funding for going for anything else, like to data analysis or data science, or like industry involving physics, or like a lot of options after that. Now, then of course you need to try to get to the best possible university, but that's obvious, right?
Yeah.
Now, I think it's quite unfortunate, actually, the system how in United States the selection of students is made. It's quite based on those SAT tests, which are, I must say, quite stupid and don't show actually the capabilities of the students. That's unfortunate, but that's what you need to do because that's the only thing. Like the only way to get there. So US universities, of course, are good, but the way they select there, this is not good. So you just need to try. Maybe you are lucky, but if not, so then it doesn't necessarily mean that you are not up to it, but just the selection system is not very good. Then now it is much more reasonable how UK universities select, like Oxford, Cambridge. They have very nice selection system, which like has more or less like Olympiad style problems. Actually, you need to solve during the interview. But then the problem with UK is money, of course, because they have high tuition fee. And guys from outside of nowadays of UK. So before Brexit, it was outside of EU, but now actually it applies also to EU countries that they need to pay high tuition fee. There are very few scholarships, so it's there are, but like exceptionally small. In exceptional cases, so it's probably very difficult to count that you get in there and then you manage to get the scholarship from there. So I guess the best what you could do is to find some sponsors, maybe government might have some scholarship for you if you get good universities. No, this varies from country to country. In some countries they do have, in the other countries they don't. Yeah, to sum up, US universities are good but difficult to get. The UK universities have good, are good and have good selection system but cost a lot of money. So now there are some other options. Singapore I have not so much experience in National University of Singapore. Which is definitely a good place to go and an option. Then there is also in Hong Kong there are good universities when you can go, and in Europe also some universities I think might have. Other countries in Europe, the problem is that they have. Undergraduate studies are usually in their native language, and so there is a language problem. Yeah. So I probably covered more or less those issues of where to go, and because everyone knows in their own country which are the best universities, and that's I don't need to explain, I guess.
Yeah, I see. And then
you ask also that what is like research, how much it is different. So yeah, as compared to Olympiad problems, of course, research is quite a lot different. And here I think I have said it in quite many occasions now if you go to research to be very successful researcher, being able to solve problems well and difficult problems, it is not the only requirement, but you need to have a lot several other components as well, like you need to be in a good research group, so you need to get problems which are like actively evolving during that problem, that moment of time, like you have, if look currently around, so in astrophysics, you have a lot of new data coming in, and so it's quite likely that you get into such topics of research which where you can really make some new contributions, important contributions. So you need to lucky, you need to have a good supervisor, you need to be in a good research group working um, uh, in problems which are really actively related to actively evolving topics of physics. And then, of course, you need to also be able to solve difficult problems. So you can think about your Olympic studies as a preparation for research, which you can do right now, because right now you cannot select yet your supervisor and research topic, but you can train yourself in being creative in solving problems. And that's definitely will be helpful as well. Well, of course, there are cases when actually students who perhaps were not very successful in Olympiads have been quite successful in research. But well, in that case, you need to be even more lucky. That you need to have also maybe a research topic where not that much creativity is involved. Just you're lucky to get good data and good code to analyze it, and you analyze and you get important results, and you might just coincidentally get good a lot of references in to your papers published and things which are needed for a successful researcher. But don't count on that. So prepare and train your problem solving skills, and you have more chances of getting good results in science.
I see. And then similarly, there some people are like interested in like wait. And then some people are interested in like your life in academia. So like, what research are you working on now, or like before, and like what do you intend to like, what new insights and discoveries you intend to make with it?
Okay, so when I did my PhD, my topic was plasma physics, which is kind of a good resource topic actually, because it has a lot of different like very wide range of parameters. Just a moment, I'll be back.
Okay. Oh sure.
Ashmit, you have like 30 seconds of.
I closed my door. All right. Yeah.
Oh wait, I think the Zoom is about to end in like 30 seconds. So I'll send you a new invite through email, and then we can.
All right.
It.
All right. All right.
All right. Yeah, I'll just end it now.
Okay.
Okay. New meeting. And then let me invite. Alright, let's see if this works. Admit. Yo. Okay, I hope he got the email. I sent it to him.
Yeah,
Oh yeah,
hopefully.
here he is.
Welcome back.
Yeah.
All right. Yeah, so we stop. It was about my research topics. So yeah, plasma physics has a very wide range of parameters. Like you have sparse plasma in interstellar space. You have very dense plasma on stars, and you have fusion plasma in tokamaks, and then you have low temperature plasmas. And so this is a really rich topic, a rich field of physics. And I studied magnetic transport of magnetic field in plasmas was more specifically. And then from there, actually, what I also got after that, continuing kind of, even though it was no longer that much related to plasma physics, but in transport, in turbulence in general, like you have turbulence velocity fields, and then how things are mixing and transported. That was one topic. But I have also studied different interdisciplinary physics problems. Like one paper was on modeling how the surface of Earth evolves due to competing action of erosion and tectonic processes.
Yeah.
And then like different scale-free phenomena, fractal structure modeling in the interdisciplinary context. And more recently, scale-free networks, like we had a research project on modeling COVID propagation over scale-free networks.
Nice. Yeah, I see. Yeah, that's really cool. Let me see another question. Okay, this is a question that someone had. So, theoretical physics often involves a lot of collaboration and interdisciplinary work. So, can you describe any particularly interesting collaborations you've been involved in and what you've learned from working with colleagues in other fields?
Mm-hmm. Well, I have worked together with geology guys, and also some doctors. We had like one research project was about modeling of heart rate variability, and then we worked together with doctors.
Nice.
And what else? That's it, probably. But what collaboration gives, of course, you can see different and new places where you can apply your physical models and physical way of thinking. It definitely is worth doing because usually guys working in those fields specifically have not so much skills in analyzing quantitatively and making models which can be treated either numerically or analytically. Like it opens you more wider range of problems what you can which are still interesting for physicists, and you can get interesting results.
I see. Yeah. And then yeah, and then This one is a bit more personal, so like it's fine if you don't want to answer. But so like they know that your children like went to like these Olympiads, like had a lot of success. So like they're asking like, oh, did you like train them or like how did you like get them like to become so good? Or this is mostly their own like self study that's got it.
I think it's okay to answer.
Yeah.
So um, yes, I did train them. More or less, I directed them towards solving problems, which I quite eager to do, and also what I mentioned before, like you can mm, optimize your studies and like study those things which are you consider important, spend more time and meanwhile skip or make like not really skip but just enough to pass those topics which you don't consider that important. And so that's what I also encouraged my my children to do. So like if they wanted to stay at home, not going to school and instead work on physics math problems, then I said okay and gave like my written permission if needed. And, they did use it from time to time as an opportunity. And then another thing is that it's useful to start as early as possible for children. So they somewhere like 6 or 7 years old, they just trained some arithmetic. There was like online nice arithmetic competition online. You just need to add fast or multiply fast in head, things like that. And then starting from 7 to 8 year old, then there was a mathematical kangaroo. I don't know if you are familiar with that.
Oh, I think I know it. I've not
The
too familiar.
mathematical kangaroo, and I think mathematical kangaroo is actually very good resource for young students, from ages from 7 to maybe 15 or something like that. Because during that time you are still not yet very prepared to do physics. You still need to work on mathematics and logical way of thinking. And those kangaroo problems are good because they are like go step by step. So there are already problems designed for 7, 8-year-old students, and just you train gradually go from to more difficult and advanced topics, and yeah, then after that, of course, it's quite more obvious. After that, you can start solving problems from different Olympiads of different levels. Start from simpler and then go to more difficult ones. And so basically, what I did just now those also take this set of kangaroo problems, solve it, and then they can check them by themselves. And in most cases they managed to do it, and in some cases maybe not. And if in some cases maybe we had a look, so what try to figure out what is the correct solution maybe, but not much needed, because if you do it systematically, you get it by yourself. You don't need so much help. Just in the way my physics and math teacher did with me during high school. That's what, more or less what I did with my children.
Yeah, I see.
Like giving step by step more difficult, leading them to step by step to more difficult problems according to how their skills advance.
Yeah, that makes sense.
Mm-hmm. And just start as early as possible. So that's another. I myself, I think I started a little late, because I started, as I mentioned, from high school, but yeah.
Yeah. Yeah. I don't think I have any more questions, but
Oh, very good.
yeah. I mean, do you have any more questions or?
Yeah,
Yes,
what I have actually, I kind of, as you know, I don't have electromagnetic handout, and I have been always planning to work on it, but then I don't. It appears I don't have enough time. So now I had a plan that because you have such a nice community, so it may be opening making open project of making such kind of thing project maybe on Overleaf or something like that. Do you think it would be feasible or would be guys willing to participate in writing such kind of thing? I would advise and maybe like say what and how and then community would help writing.
Yeah, I definitely think we could do that. I wasn't expecting that. Yeah, and I think like we have like a lot of people in the Discord server who would like be more than willing to help out with it.
you have a cult following, so they will definitely do that.
Mm-hmm. So I can also put those existing handouts into Overleaf and open the project some if there are some things which can have mistakes maybe or things to fix. They can also go to as open projects. But if I put them to Overleaf, I would there are limit to the number of participants, and it needs to be somehow to agree who will like actively work, and then there is of course also possibility to give editable link, but that's probably not very safe. So it would be better to just based on invitations. In which case, I think I don't remember what is the number of number of participants, but it's still not very small. Something 7 or 8 or maybe something like that is probably still okay. Yeah, that's probably okay. All right, so I look into it and then keep you informed when I have moved on with that.
Yeah, awesome. That'd be definitely really cool. And I can like ask people who would be interested. I can.
Yeah, you ask who feels like confidence they can do it and who are interested. So just let me know then about the results, and then I can move on with this.
All right.
Mm-hmm.
Yeah.
All right.
I guess that's it.
Okay, thank you for for organizing this and
yeah, thank you so much for
everyone.
coming over.
Good luck to everyone.
Yeah, it was like really nice meeting you and like hearing all like the different things you had to say.
Mm-hmm.
But yeah, I guess see you.
Voilà. Yeah.
All right.
See you. Bye-bye.
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 Oh, I didn't mean to do that. Okay. Wait, that was actually really cool. Oh, you guys had some questions that I was not reading. Okay, I guess that's it. Yeah, that was really cool to meet him and like talk with him and like hear everything he had to say. But yeah, like I guess we can talk about the E&M handout and like everything. I'm trying to make a video because I don't know if the live stream will like last, so I'll probably make a video. I have everything recorded, I think.